Hi everyone, it's Ms. Schieber. In this video I'm going to be teaching you kind of a trick for how to make structural formulas out of molecular formulas. It's just some patterns that tend to happen that are going to make it easier for you to figure out some structural formulas. And the trick is called the Honc 1, 2, 3, 4 rule. Yeah, it has a fun name there. So let's start with this. Here are some structural formulas of 3 different covalently bonded molecules. Take a look at the different atoms and try to count how many lines are connected to each type of atom. And that also means how many bonds are attached to that atom. Okay, so take a second, pause the video, and try to count for carbon, oxygen, nitrogen, and hydrogen. How many bonds does each of them have? All right, so for carbon, you should have counted that they all have 4 lines attached to them, or 4 bonds. So like, you can look at any carbon, but here's one, and it's got 1, 2, 3, 4 lines, or 4 bonds. Another carbon, 1, 2, 3, 4, so carbon tends to bond 4 times. Oxygen, if we find an oxygen, here's one, tends to bond 2 times. If we look at this oxygen, it's only connected to one thing, which is carbon, but it's connected twice. It's got 2 bonds to that carbon, so it's still making 2 bonds. If we look at nitrogen, there's a nitrogen right here, and it has 1, 2, 3 bonds. And finally, all of the hydrogens, you should notice, only are connected by 1 line. They only make 1 bond. So we can refer to this pattern as the Honc 1, 2, 3, 4 rule. Let's just fix that. There we go. Where hydrogen makes 1 bond, oxygen makes 2 bonds, nitrogen makes 3 bonds, carbon makes 4 bonds. Honc 1, 2, 3, 4. So hydrogen, oxygen, nitrogen, and carbon are the most common nonmetals that you're going to find in covalently bonded molecules. There's a few other nonmetals in there like fluorine or sulfur, and we'll learn about what kind of bonds those form later, but for now we can make a lot of different molecules just using these 4. Okay. Quick note that things can form multiple bonds between the 2 same atoms. So in this picture, right, we've got just 1 line, and we would refer to that as a single bond. In this picture, this bond is a double bond. So these 2 carbons are bonding to each other twice, and then you can even have a triple bond where they're bonding to each other 3 times. And notice in all of these molecules, the carbon is still making 4 total bonds. It's just bonding more times with one thing in the triple bond or the double bond. So you've got a molecular formula like this. How do we figure out a valid structural formula? So there's 3 kind of basic steps. The first thing you want to do is deal with the carbons. Chain all of those carbons together. So in this example here, there are 2 carbons. So I'm going to bond those 2 carbons. Next thing we want to do is add the oxygen and or nitrogen atoms. So in this one we've got 1 oxygen atom, so we'll just attach that to the carbons as well. And finally we want to add in our hydrogen atoms. We've got 6 of them, and carbon needs to bond 4 times, so we must have a hydrogen, hydrogen, hydrogen like that. That's 1, 2, 3. This carbon and second one already has 2 bonds, so we need 2 more. So bond to 2 more hydrogens. And then oxygen should have 2 bonds. So we'll stick another hydrogen on there. And we have 1, 2, 3, 4, 5, 6 hydrogens, correct number of hydrogens. can double check my structure. Does everything have the number of bonds it's supposed to have? Yes, it does. So this is a valid structural formula for that. Now remember, there can be multiple correct structural formulas for any given molecular formula. So this is the same one that was on the last slide. C2H6O. There could possibly be other ways we could have arranged that. For example, I could have put the oxygen in the middle of the two carbons and done it like this. And if I check, my oxygen's got 2 bonds, carbons each have 4 bonds, hydrogens each have 1 bond. That satisfies my rule. So this could be another alternate formula for that. So we call these molecules that have the same molecular formula but different structural formulas isomers. So for this kind of question, there's not always just one